getting back to the browsers. All right. So this is the homework. Oh, wrong class. This is the Friday class. This homework is already due, at 8 o'clock, so I cannot accept any submissions after this because I will be talking about the solution to that homework. But I can use the next one to illustrate how to turn in your homework using the HTML editor. So you just click on the homework itself, and then the next thing you should see is the description of the homework. It's a little bit slow today. Okay. So when you see this description here, there's one submission already. That's impressive. I just put it up like about 6 hours ago. Somebody worked overnight,
Was that about midnight?
It was about midnight, yeah. But that's still. I have to switch to a student role first, and then I can go to the homework, so you will see, I will see exactly what you should be seeing. So this is what you should be seeing, and at the bottom of the screen, it will say you have not submitted anything yet, which is normal because I haven't really done anything with this homework yet. So the next thing to do is to click Edit My Submission. So when you click that, it will refresh the page, but it will also give you an HTML editor. Now, is that what everybody can see? Did you see this part here? No? Did you click the button?
You have to hit Edit Submission and then it pops up.
Yeah. Did you click the other button that we saw earlier? You did? So what do you see when you click that button? After you click that button, what do you see?
This page.
Did you scroll down? It's at the bottom of the page. Well, it's at the bottom of the page, so you have to scroll down to see the editor. Okay? So then in the editor, this is an HTML editor, which means it is perfectly safe to use the less than and the greater than symbols. And you can also copy and paste from Notepad into this page here. I would not copy and paste from Microsoft Word. Okay, that has been known to have certain issues. So definitely, WordPad is okay if you have, since we all have OpenOffice installed. OpenOffice Writer would also work perfectly fine. Those are the products that I know for sure will work. So you can just copy and paste from Notepad, and you can just, I'll just go ahead and write something here. Okay, this is definitely not the answer, but I'll type something here. After you type something, it is not automatically saved. You have to scroll all the way to the bottom again, and then this time you click Save Changes. After you click Save Changes, make sure you scroll down again, and make sure that Moodle uses the green text to confirm that your changes have been saved, and this is what it has saved. If it does not save what you think it should save, then you have some sort of an issue. The formatting may not be preserved. In other words, if you use a lot of leading spaces, those leading spaces will be gone on each line. But that's fine. I can still read, line by line, so it's not a big issue. But if you see important stuff missing from your text, then you should do it again, but possibly using a different browser. I know for sure this does not work very well with Chrome or Safari, because with those browsers, it does not give you the HTML editor. It gives you a plain editor, which is not HTML. Whatever you type in those windows will be interpreted as HTML tags. And that's why the less than and the greater than symbols will have problems, because the less than symbol is also the open angle bracket in HTML, and then the greater than symbol is the close of that particular symbol. So your submission would be messed up if you use any browser other than Mozilla Firefox or Internet Explorer. So that's why it is important to use Mozilla Firefox for the homework purposes. Are there any questions about how to turn in homework assignments? Yep.
Is there a way to get the mathematical symbols? I'm sorry.
That's okay. Go ahead.
The mathematical symbols in that editor, like the conjunction?
The conjunction symbols, I think there's a way to do it, but you don't have to do it. Just type and.
Just type and. Okay.
Yeah. Go ahead.
That's Opera.
You have to check first, because Opera I know has the ability to pretend to be another browser. So if it pretends to be another browser, Moodle will try to load the same HTML editor. Then it's up to the JavaScript compatibility to see whether it will work or not. So I would, for safety reasons, I would still use Mozilla Firefox, just to be sure that it will work. I know some of you do not like, Firefox for one reason or another. But for turning in the homework in this class, I think it is best to use Firefox to make sure that whatever you do, gets turned in. Okay. Are there any questions? No questions? Did I address your problem? No.
No, it was still the same page, so it says like you didn't it, so it doesn't work. If I click like a few times, but it still doesn't work.
Okay. What did you click a few times? Edit my submission?
Yes.
Were you using Firefox?
Yeah. When I scroll down, it's still like that you write and it doesn't show.
Okay. Do you get to this page here? Did
No.
you scroll down? Did you scroll down and there's no editor?
No, it was just a page, the homework, but it wasn't this.
I don't know because that's not an issue that I have encountered, so I can't really diagnose the problem. My only recommendation in that case is you have to go to portableapps.com, and from here you can get the portable version of Firefox. So you go to the portable version of Firefox, and you go ahead and install this on the thumb drive. And that should be completely independent to the one that you're running on your computer, and hopefully this one will work. So that's your best bet. I mean, other than that, you have to use another computer possibly, to see if that other Firefox is working. But without any screenshots, I cannot tell what is wrong, and I cannot help you to get that problem fixed. Okay. Any other questions? Questions? Okay. Okay, but since we're here, this is your new homework assignment, which is not really that difficult, I don't think. The HTML, this is, okay, so this time, I'm, a little more careful. I remind people to use Firefox instead of the other types of browsers. I know Chrome is fast. If you're after speed, Firefox 4.0 is also really fast. I have been using Firefox 4.0 beta for some times, and it's really stable. I don't have any problems with it, but that's just personal choice. Okay, this is the pseudocode that you have to derive the pre and post conditions for, and this time the precondition is not true. This time the precondition is we know x equals to k. Now we don't know what k is, but we know that it is k. And you can see that k is not used anywhere within the program itself, so k does not change over time. This is the only way we can compare the final value of x as opposed to its original value, because we use k as quote-unquote an anchor at the beginning of the code that we want to track, and then we can say, okay, how does x relate to k when this code is all done? So your responsibility is to derive pre-2, post-2, pre-4, post-4, and you might want to review the pre and post condition discussion on conditional statements, because that's really relevant to what we are doing here. For each derivation, you have to include the following, which is basically the same stuff as what we have talked about so far. Are there any questions about this new homework assignment? You have 1 week to work on it.
When is the test?
The test is not going to be there until I'm done with the top-down design topic. In other words, at this point, we don't have enough material for a test.
When do you think we're going to be done with the top-down design?
Hopefully sometime today. The first part of today's lecture is going to be focusing on loops, the pre and post conditions of loops. And then the second half, we'll get to top-down design. So possibly next Friday we'll have a practice test, and then after next Friday we'll have the actual exam one. Okay? So that means you always have at least 1 week from the practice test, to the actual test. So that way you will never be caught, by surprise. Any other questions? No questions? Okay. Any questions about the homework itself?
Are we going to go over it? Or? Are we going to go over it?
Well, I just did.
Oh, did you? Oh, okay.
Do you want to go over like the
answers? Yes.
Oh, the answer of the one due today?
Yeah, not.
Oh, okay, sure. Yeah, I forgot about it. Sorry. Okay, the one that's due today, which is this one here. This one is, it's a mixture of stuff. So what we'll do is I will use a plain text editor to do it. And I'll start with copying the original code. X gets a value of 2. Y gets the value of x, 23. X gets x plus 3. And the last one is y gets y times 2. Okay. Make sure I save the file to the right folder. So I'm saving the file to today's folder, which means at the end of today's class, if someone reminds me to upload it, it will be on Moodle on the same day. Yep.
I have a question about the code.
Okay.
On line 2, I think it is, this says y gets the value of x.
Yep.
And then on line 3, the value of x changes.
Yep.
Does y change as well because it has the value of x?
No,
or does
it does
stay
not.
The same?
No, once y gets the value of x, they are independent.
Okay.
So x can change all it wants, but y gets to retain its own value.
Okay.
Yep. Okay. That's another difference between math and programming, because in math, when you say y equals to x, well, I guess that's a statement saying that y equals to x at that time, but it doesn't really state whether y stays the same as x afterwards. Yep.
Yeah, I had a question about the .text files. What should I open that in
With?
to be able to keep the formatting?
WordPad, not Notepad.
Yeah, WordPad will work. Yep. Okay. Or you can also use one of the free editors from portable apps, like Notepad++. Let me see if that's one of the choices from that website. Portable apps, has a lot of really useful applications, not just the browser. Let me see if I can find Notepad. And they have Notepad++. That's a really cool, useful editor for programmers. So it's not only useful for this class, it will open up the text files without any problems from this class. But in your other classes, like cisp300, Notepad++ will also be a very useful editor for that class.
Also for the HTML.
It also does HTML?
Yeah.
Cool.
Yeah.
So it has syntax highlighting and all that stuff. Excellent.
Yeah.
And it's free.
Yeah, it's kind of.
It's free. It is not that small. For an editor, it takes up 10 megabytes installed. But these days you have 4 gigabyte flash drive, so it's that much of your storage. Okay, so getting back to the homework assignment. Okay, we'll start with the precondition. The precondition is we know x equals to 20 and y is less than 20. So I'll just go ahead and copy that, put it here. Okay, how do we get to the post of 21? Well, first of all, we have to ask which rule should we apply? How do we know which rule we should apply? Well, the first thing is to look at the right-hand side of the assignment statement and see if it refers to the left-hand side. In the case of line 21, the right-hand side does not refer to the left-hand side, because the right-hand side is nothing more than just a constant 2, which does not refer to the variable x. And right away, because the right-hand side does not refer to the left-hand side, we know that we have to use the forget rule. Is that okay? Okay. So the first thing is already done. Now that we know we have to use the forget rule, you have to give me the general form of using the forget rule. The general form of using the forget rule is the post condition would equal to the precondition, but you have to toss away some information. Anything that we know about x has to be removed, because now that we have changed the value of x, whatever was true before may not be true anymore. But on top of that, we also know that from now on, x does equal to 2. So you have to start with this as the first line, okay, which is basically the format of the forget rule. If you go to the notes and have even more abstract stuff like uppercase x here and expr here, that will also be okay. But this is what I'm looking for. The second line is just going to expand what is pre-21. And personally, I would just copy and paste. I mean, that's the easiest way to do it. And then the third line will apply the actual forget operation. In other words, you look at this expression here, and then you ask yourself, which part of this refers to the variable x? Well, I don't think it is too hard to identify. This is the only part that refers to x. So you have to get rid of this part here, and the only part that will be left is y is less than 20. So the result of the forget operation is we only have x is less than 20 left, and on top of that we also know that x equals to 2, and that's the answer. Yep.
Why don't you include y is less than 20 on the first line?
On the first line.
Of the post.
You mean this one here?
Yeah.
Because I want to know where it came from. But this is the general format. The post condition of an assignment depends on the precondition.
And it's a precondition.
Right, but this states the precondition. So I want the precondition to be stated here, and then you expand that or substitute it with the actual precondition on the next line. It's not a big deal. If I can see if it's obvious, I suppose it will still be okay. Yep.
And after it says pre-21, comma x. It's the only reason you're stating that is to affect x, right? It's not affecting y whatsoever. You're affecting the precondition of
correct.
X.
Okay.
And that's
Yep.
why you're stating that, correct?
Yep.
Okay.
Mhm. Because this is a general format, and if you get to this part here and you run out of time, I will still give you partial credit in the test. Because at least getting to this part means you know what you have to do. The rest is mechanically actually going to do it. Okay, is that all right? The rationale of why I would like people to have this line first, because it's the template. This is the template to apply, and we want things to be mechanical. Okay, we want things to be really step by step and mechanical, and this is mechanically the first step is to identify that we have to use the forget rule and the precondition goes here, and then we expand it in the next one. But as I said, if you turn in your homework and you did not indicate the pre-21, and since it is obvious, it will still be okay. Okay, so we're done with line 21, and then on line 22, the first thing we want to do is to say pre-22 equals to post-21, because these two statements are sequential. If you don't explain it, that's okay, but I still need to see why, the post condition of 1, how it relates to the precondition of the next line. So if I were you, I would just put down a little statement here, because line 22 follows line 21, which is not always the case. In the case of a conditional statement, you cannot apply that logic anymore, because in a conditional statement, you can jump from one line all the way to like 2 lines later, so you cannot apply that this type of reasoning. This only applies when the statements are truly sequential. One follows the other one.
Or in a loop, it wouldn't. If you're dealing with a loop.
Correct. In a loop, especially at the end of a loop, that's really tricky. We'll get to that part in today's lecture. Okay, line 22. On line 22, we apply pretty much the same reasoning. If you wish to, you can just repeat this statement here. The right-hand side does not refer to the left-hand side. On line 22, so we have to use the forget rule again. And the forget rule, just like the previous one, post-22, is based on pre-22. But this time, instead of forgetting everything that we know about x, we have to forget everything that we know about y, because y is here. And after this, y equals to x. Is that okay? Then we just go ahead and find out what is pre-22. Since pre-22 is the same as post-21, and this is post-21, we copy and paste it here. If you look at this statement here, we know that the first part is the one that refers to y. So we have to remove that component. So that means we have x equals to 2 left, and then after that we have y equals to x. Now someone can say, but Tech, we could have kept y is less than 20, right? Because x equals 2 and y equals x implies that y is still less than 20. Now, but if you think about that, if you think in that direction, then you have to ask yourself, does it add any information to what we already know? In other words, if I already tell you that y equals 2 because of the other two conditions, and you add on top of that and say, oh, I also know that y is less than 20, does that last piece of comparison give you any extra information?
No.
It does not. Okay, so that's why one, it is not a part of the procedure to keep it. In general, it does not work, and two, it does not even add any new information to what we already know, and that's why we do not keep y is less than 20, even though in this very specific case, keeping it would not have hurt. Now, some people may actually go ahead and simplify this even more and say that y equals 2.
Yeah, because see, this is why I was asking, because if you just drop down y is equal to x, and then you start changing x again, then your conditions are going to change.
It does not, interestingly. It does change, but the way it changes, it does not affect what you know about y. So we'll take a look at that, okay? I know what the question is, but we'll take a look at it, okay? The substitution rule will actually take care of what you were just mentioning. Okay, so we'll take a look at that. So we're moving on to line 23 at this point. Line 23, we have to.
At this point, you don't make y 2.
You can, but since I did not talk about it in the class, you are not required to make that. Take one more step to state that. Okay, the question was, at this point, since we know x equals 2 and y equals x, we can also basically claim y equals 2. Okay, and that is absolutely true. You can put that information here, and it is actually useful. Okay, to decouple the two variables is useful. But since I did not talk about it in the class, you are not required to do it. If you do it, that's cool. If you don't do it, it's just as cool. Okay. So now we're moving on to line 23. On line 23, the right-hand side is x plus 3, and the left-hand side is x. So in this case, the right-hand side does refer to the left-hand side. So we have to state that first. The right-hand side refers to the left-hand side on line 23, and the right-hand side is reversible. In other words, x plus 3 can be reversed by x minus 3. Very good. Okay. So in this case, I have to define a function. If f of x is x plus 3, then the inverse function f prime of x is going to be x minus 3. Are we doing okay so far? Identifying what the inverse function is. And then after that, we can apply.
How do you make that little 1? I was typing out. I'll type out inverse.
Just the apostrophe is the the lowercase version of the double quote.
Gotcha.
But as long as I understand what you're saying, that's still okay. Some people, in the past, some people just use this, and basically without the superscript, that's fine too. As long as I understand what it is fine.
Okay.
The HTML editor, interesting, will let you do superscript. But it's a lot more cumbersome to do the superscript than to use the apostrophe.
Gotcha.
Forgot to give the pre. You forgot to give the pre for line 23.
Oh, that's right. We have to derive the pre from the previous line. So you say pre 23 is post 22. So that makes the association of those two. And then you say the post condition of line 23 is the result of a substitution operation. The substitution operation will take pre 23 to begin with. We take all occurrences of x, which is the variable on the left-hand side, and replace it with f prime applied to x. And And in the next line, I just take a look at what is pre-23, it is post-22, and post-22 is this here. So you just put the whole thing here, and then you put x and f prime of x. F prime of x is x minus 3, so we just put x minus 3. I always put that in parentheses, so that I can just take this chunk of text and put it into wherever x is, and it will never mess up anything, even if x was used in a multiplication, which we don't have here. So after the substitution operation, the first x here, x equals 2, this x gets replaced by x minus 3. So we have x minus 3 here equals 2, and the second one is y equals x minus 3. Now that is actually taking care of the problem that you mentioned earlier, because the value of this x after line 23 executes, this is the post line 23 value of x.
The post 23 value is the pre-value minus 3.
It is the post line 23 value of x minus 3. In other words, if you look at x minus 3, it becomes the same value as the pre-23x. And that's why the relationship still holds, because I am undoing what line 23 is doing to x, and then I say that undone value will still be the same as y. And that's why it still works.
Okay.
In other words, the mechanical procedure, will still be fine, even though, it's not as good as, stating earlier that y equals 2.
Oh yeah, it's way easier to just say.
Yeah. Mm-hmm. But this still works. And for those of you who want to simplify, you can always take that one more step and simplify and say x equals to 5. But that's not required. Okay, you just have to know mechanically how to derive these steps. So I'll just leave it like this. Okay, not simplifying is good in a way because you don't have to take it one more step, for this part. But you pay the price later because the expression will get longer and more convoluted as you go. So it's up to you to decide whether you want to simplify or not, depending on how comfortable you are with algebra.
You can't simplify both sides?
You cannot simplify both sides in this case because this side refers to x.
But
if you
don't you solve for x on the left-hand side for the post?
On the left-hand side?
Don't you get x is 5?
Yeah.
So can't you put 5 minus 3? And then get y is 2?
No. You mean on this side?
Yeah, can't you plug in 5 for that x?
Yeah, you can. Yeah, but to get to y equals 2 is actually easier in the earlier step, because if you state here y equals 2 in the earlier step, then it doesn't even get changed because there's no dependency between those two variables anymore.
Mm-hmm.
Okay, but I did not talk about it in the class, so I would not be expecting it. I would not assign point values to that one extra step.
So that wouldn't be wrong?
It would not be wrong at all.
Because I think that's what I put.
Let me just go back here and do that, okay? But I will make sure that it is stated as optional. Okay, so this is optional step. Okay? Because if you take that one extra step, then in this step here, y does not equal to x anymore. It just equals 2. And the substitution operation will not have done anything to y at all because it does not refer to x. Mm-hmm. But even the way it is right now, it still resolves correctly. It's just more cumbersome at this point. Okay, so that's a good point. That's a good point. So in this case, I can also say, and as an extra step, you can say x equals 5 and y equals 5 minus 3 equals 2, and I will just say this is an optional step. Okay, so we are down to the last one. The last one is y gets y times 2. And the same thing here, the right-hand side refers to the left-hand side, and the right-hand side is reversible. I'm just going to copy that. Change line 23 to line 24. So this time, if you want to, just use a different name, g of y equals to y times 2, so that the inverse g prime...
You forgot to say the post and pre equal or whatever.
Yeah, I stated after the inverse function thing. It's okay, you can do it before or after.
Oh, okay.
Yeah, as long as it is before you refer to the precondition, that's still okay. So g prime of y is going to be y divided by 2. So at this point, I can make that statement and say pre-24 depends on is post-23 because those two statements are sequential.
Why did you use G?
Just so that I don't confuse the function with f. You can use f if you want to. That's fine. Because as long as because I use f already here. So if I refer to g f of y is y times 2, it might cause confusion if people are not used to this kind of thing. So you don't have to. I use g simply because it is not the same function as we had before. But if you use f, that's fine because I understand what you're referring to. Okay. It's basically a scoping problem. In other words, how long does the definition of f stays? Okay, for which portion of the homework does it stay? But since we don't really talk about the scope of function f, I just use a different function name so that it will be more clear that way. But you don't have to do it that way. Okay, pre-24 is post-23 because these two statements are sequential. And now we can just go ahead and apply post-24 is based on the substitution of pre-24. We take all occurrences of y because y is the one on the left-hand side, and we replace it with g prime, the inverse function, applied to y. On the next line, we expand what is pre-24. Pre-24 is post-23, and post-23 is this mess here. So I will start with just the one that I have. If you simplify, it makes your job a whole lot easier. But if you don't, it gets a little messier. But everything still works out in the end. Okay. G prime of y is y divided by 2, and I put that in parentheses so I can really just do the substitution. Now let me show you another trick that you can also use if your editor supports it. What I can do here is instead of manually scanning through this and find all occurrences of y and replace it with y minus y divided by 2, I can ask the editor to do that. So I go here and go, oops, no, go away. Search, replace, but this time you have to be sure that you select only the selected text. I do that. Nope, this editor does not have that feature. I can do one by one, so that will still be okay. So I'm going to replace y with y divided by 2. And it doesn't let me specify. If I don't wrap around, I will still be okay because this is the only portion of the text that I want to perform the replacement. So find. Oh, it's going to replace them all. Mm-hmm. That would not be good. Mm-hmm. I can't.
If you scroll through the find, it'll highlight the one that you're on, and then you can select just that one, go on the end. But you have to go through.
Are you using the same editor?
Get it?
Are you using the same editor?
Yeah.
Okay. Let me try it one more time. It doesn't keep the selection. That's the problem. It does not know what I have selected.
See, now it's looking for the whole.
Right, because I forgot to change this part.
So if you start hitting find right now, it'll scroll through all
again.
the finds, or all the Y's that it finds.
If I click find?
It should highlight the one that you're on. Yeah, keep
finding it.
There you
No. Still finding all of them.
No, finding is just highlighting all the Y's. So unless I actually click on replace all or replace, it doesn't actually do it. Okay, I'll just not be lazy and do it myself.
go. I know there's a way to do it, but
It depends on the editor. Notepad++ almost for sure will do this. You can select, text, and then when you do the search and replace, you can say only apply to the selected text. So that limits, where the replacement can occur. Okay, so that's the answer. That's it. Okay, this is the final answer. This is what I'm expecting. Just doing everything mechanically. You don't even have to apply algebra to simplify everything. And it still works. The thing is it still works because according to this, if you want to take this one more step, you see that x equals 5. Okay, that's fine. Okay, But if you work on the other side, the first thing you will see is y equals to 2 times x minus 3. And then you just take that one more step. Because x equals 5, 5 minus 3 is 2, 2 times 2 is 4. So you still get to the same solution. Obviously, these two steps are optional. Okay, optional step. And more optional step. So are we doing okay so far with the concepts of pre and post conditions? Okay. Let me save the file again, just to make sure that at the end of the class I can upload this to the server. And now we are moving on to loops. Now loops are kind of evil. Okay, they're kind of evil because because when you think about the pre and post conditions, at least up to this point, even with conditional statements, they all go in one direction. Okay, we start here, and then we can choose this way or this way, but either way will merge, and then we keep going down, right? But with a loop, guess what? We can go back up. So that makes it kind of complicated because the post condition of one statement becomes the precondition of an earlier statement. Okay, which is something that we haven't seen before. That makes loops, very special when we have to analyze the pre and the post conditions. So let me just point you to the notes first. It is this particular part here that we will be talking about today. And this is an example, and I can make the example actually a little bit more general, but this is good. I think it's good to use, just concrete values. So this way, we can just go, just use this as an example. Okay. The text actually describes, everything that I will be talking about. In other words, if you read the text and understand it, there's no new information that I'll be presenting in today's lecture. But instead of just talking about the text, I'll use a picture to represent, the code here, and then I'll circle certain parts of the path and say, what do we know at this point? What do we know at this point? What do we know at this point? Because that gives you a more graphical representation of the logic, and hopefully that makes it a little bit easier to kind of pick up the concepts behind it. So let me pass the worksheet around. Okay, we'll start with the incoming path. And the first thing that we do is x gets a value of 0. Okay, so I'm just drawing a picture that is the same as the logic in the pseudocode. And remember, this part is not being captured in any way, so if you want to keep it, you have to draw the picture yourself. Okay, then we get into the loop. Now, since this is what we call a pre-checking loop, you first have to draw the merge before you draw the rest, because the merge comes before the branch. The next thing you do is to draw the branch. It is always helpful to add additional arrows so that you can only come in from this branch and you can get out from these two branches. If we continue the loop, okay, this is the true branch, we're continuing with one more iteration. What we do inside here is just saying x gets x plus 1. We're adding 1 to x. But after we perform that operation, we have to go back to the beginning and check the condition again. Every time you have a branch like this, you have to ask yourself a question. Depending on the answer to that question, you decide which way to go. So in this case, you have to ask yourself a question. X is less than 3 is a question. Is x less than 3? Is it true or is it false? If the answer is false, then you bypass everything and you continue with the next statement. Are there any questions about the shape of the loop here? Yep.
Is that a precondition loop?
This is a pre-checking loop. Yep. Because we check the condition first before we perform the operation. Okay, so now we want to analyze the pre and post conditions. In this case, let's just say that the condition here is true. In other words, we don't know anything about x prior to this point. well, we don't need to know anything about x prior to this point, because guess what? The next statement, x gets 0, is going to reset or rewrite the value of x to 0 anyway. So whatever we knew about x is going to be gone anyway. So we don't have to really deal with that much. Okay. Now, without having to go through all the forget and all the other trouble, we kind of know that at this point the condition is x equals to 0. Is that okay? That's right? Okay. Okay, the next one is here. Okay, I'm skipping a few and just going to skip all the way down to here. And guess what? I won't even tell you what it is. I'll just say this is post 3. Because this is line 3, and the condition after line 3 is post 3. Yep.
Would there ever be a situation where the loop might go in before the x equals 0, so that like it would never end or whatever?
No, it should not happen like that.
Okay.
The only case where that can possibly happen, excuse me. Excuse me. Yeah, I saw that coming, and then we're like, okay, wait, hold on. The only thing that can happen is when you have go-tos, like you put a label inside here and then somewhere else has a go-to. But eventually it still has to come back to this point and check the condition.
Okay.
Yep, go ahead.
What are you saying is like, basically you put like, you make your while loop, and like your while is x less than 3, and then your next statement x equals 0, and then it just...
Oh, so you put x equals 0 inside the loop?
Yeah.
Okay, I see. If you did that, yes, it will become...
infinite.
It can become an infinite loop.
But would there be any case where you would want that, or is that like considered?
No. not in normal programming.
Okay.
You know, some people think of really obscure ways of doing things. So some people may do something like that, but there's no need to do things like that. In other words, I don't see any need to initialize x inside the loop here.
Okay.
Yeah, the only case is you have certain conditions that you can detect inside the loop, which basically requires the reset of the value of x. But in those cases, x gets 0 should be guarded by a conditional statement inside the loop itself.
Okay.
But even so, it's bad practice to do it that way. Okay, so I'll just say this is post 3 immediately after the statement x gets x plus 1. And the reason why I just use post 3 is because it's kind of hard to find out what it is. Okay, knowing this is post 3, we can now go back in time and try to figure out what is this guy here. Well, it's just pre-3, right? Well, pre-3 is the name of it, but what does it actually equal to? That's the question, okay? So I'm just going to bring it out here. You have to think about all the different ways that we can end up here. One way to end up here is at the very beginning, we get into here not from looping back, but from the first statement, the statement before the loop. Does it make sense that we can get to this point here just coming from here, and this is our first way to get here? Make sense? Okay. So that means the pre-3, let me just use different colors here. Pre-3 equals 2. The first part is, okay, x equals to 0. That's the first thing. And that's coming from here. But after the first iteration, now when I'm standing here, I do not know whether I came straight from outside or I came from looping back. So when I'm standing here, the other way to get to here is going from the statement itself, and the loop made me get back to this point. So I can say or post 3. Is that making any sense? That I have to use an or because when I'm standing here, I don't know which way I came from. So I'm going to use the color here to kind of correlate the condition with the picture. Okay, but regardless of how I got back here, okay, so I take another pair of parentheses, surround these guys. Regardless, I also know that one condition has to be true all the time. Because either way, if I could get through here like this, or if I loop back like this, I still have to get past this question here. X is less than 3 has to be true in order for me to end up here. So we have one last condition here and say that x is less than 3 has to be true. Is that making any sense so far? Okay. Now we have a problem, don't we? What is my problem? The problem is the precondition of line 3 has a component that refers to the post condition of exactly the same line. Is that right? Now, at this point, I can go back to the text editor. So I will try to capture as much as I can. I can draw pictures electronically. It just doesn't work out too quickly. It's not very effective, and that's why I keep this part on the whiteboard. But as soon as I can switch back to the notepad, I will use the notepad. Okay. So at this point, we know one thing. We know pre-3 is kind of like a big gibberish thing, because the first thing we know is x equals to 0. We can come straight in. We can come in from outside of the loop, or we can come back after at least one iteration, which means post 3 has to be true. But in either case, I know in order to get to that point, x has to be less than 3. So I'm just repeating what I have written on the board without all the color highlighting and stuff like that. Now, what is post 3? Well, post 3 is not that complicated. Okay, I know that I can apply everything that I knew about assignment statements. The right-hand side of line 3 refers to the left-hand side. X plus 1 has an inverse of x minus 1, and as a result, I should use the substitution rule. That's not a problem. I know that I have to use a substitution rule. And I know exactly what to put here too. I have to substitute in pre-3 all mentioning of x with f prime applied to x. F prime in this case, f of x is x plus 1, f prime of x is x minus 1. In other words, it's almost a trivial case for this example. The problem is, if I try to do this, okay, let's see what happens when I try to do that. Okay, what exactly is pre-3? Pre-3 is this mess here. What is the problem? The problem is we have post 3 here, we have post 3 here. I cannot resolve what post 3 really is looking at this. Is that making any sense? Mm-hmm. Okay. So for those of you who have read the notes, there's no real solution, there's no mechanical step to find out what is post 3. You can have all kinds of suspicion. Usually it's based on the condition, the exit condition itself. But in this case, I'll just say that TAC has a suspicion that x is less than or equal to 3 is the proper precondition. Okay, so we'll go ahead and do that. So TAC suspects that x is less than or equal to 3. Okay, it's not just x is less than, it's x is less than or equal to 3 is, okay, we can just do this here. Post 3 is that. Okay. Now, it's only a suspicion, and don't ask me why I'm suspecting that. Okay? But given that this is my suspicion, is there a way to verify whether I'm right or not?
Yeah, because it wouldn't have gotten to that point if that wasn't true, right?
I could plug it in.
Yeah, x is 0.
Okay, now if I have a suspicion that post 3 is x is less than or equal to 3, I can plug this into here and see if the substitution operation works out.
Oh, okay.
Right?
Uh-huh.
So that's one way for me to double check and see if my suspicion is going to be consistent at least. Okay. So let's plug this into the post 3 equation and see if it works out. Okay, because at this point it does not seem that it will work out at all, but in reality it does.
Got a small typo. Equation and if, or you lift out C.
Equation and see if it works out.
There you go.
All right. So now we'll just go ahead and copy. I'm just lazy and just copy and paste everything here. But instead of having a post 3 here, since we suspect that post 3 is nothing more than x is less than or equal to 3, we'll just put that here. Okay? Well, the substitution is going to be a big mess. So what I want to do is to see if I can simplify this junk here. Is there a way to simplify it? Well, first of all, we work from the inside out. In other words, we look inside the deepest level of all the parentheses nested. And then we say, let's look at this part here. Let's just look at this disjunction here and see if we can simplify it. Do you think there's a way to simplify this?
Well, didn't we state earlier that because we know that x is 0 or whatever, and x is less than or equal to 3, it doesn't define it any more than what we already know? Can we just use only x equals 0?
In this case, it's the opposite.
It's using x.
Now, in that case, in the earlier case, it was a conjunction.
Okay.
Now, when you have a conjunction and one side includes the other side, you pick the restrictive one.
But if it's that's if it's and then if it's
Correct.
or,
Then you take the more inclusive one.
Okay.
Okay, so that's right. That's the right kind of thinking. Is to say, okay, we know that one case includes the other one. Is everybody convinced that one condition here is completely included in the other one? In this case, x equals to 0 is a special case of x is less than or equal to 3. Now, but when you think about it, x equals to 0 implies x is less than or equal to 3, but the implication doesn't go the other way around. If I just tell you that x is less than or equal to 3, it does not automatically imply that x is 0. X can be negative 1, can be 1, can be 2, can be negative gazillion, right? So that's why you have to be careful with a disjunction. You pick the one that is more inclusive. With a conjunction, you pick the one that is more restrictive. Okay, but that's the right kind of thinking. So we will go ahead and copy and paste it. I'm doing the simplification because that makes our job a whole lot easier down the line. Because otherwise we'll have all this search and replace, and only to find out that, oh, okay, we could have done that earlier. Okay, so now we have this form here. And let me just copy and paste and highlight the part that I think maybe we can do something about it. Maybe we can simplify it. Can we simplify this one? Do you think one case is inclusive of the other case? If I tell you that x is less than or equal to 3, and I tell you x is less than 3, which one is kind of redundant? I really
X
do
is
not have to
less
say
than
that.
x is less than 3.
Less than or equal to, because this time it's a conjunction.
Oh,
Okay, this time it's a conjunction. So in the case of a conjunction, we go for the more restrictive case. It is more restrictive to say that x is less than 3 than to say x is less than or equal to 3. So in this case, we pick x is, we let x is less than 3, remain here, and then we take out the other one. So we just say we keep x is less than 3. Are we doing okay so far with this? Okay. Well, let me just ask you, do you think there's a class that will teach you about all this stuff here? No?
No.
Oh, there are classes that will teach you this stuff here. Let me see. Okay, I'm distracting myself here. But I think for those people who are interested in getting a handle on these things, which will be very helpful, why do you think it's going to be helpful as a programmer or someone who will be writing programs? Maybe not professionally as a programmer, but for anyone who will be writing programs to understand this stuff here. Why would that be useful?
You just need to understand the logic behind the program, how it's working.
Exactly, because sometimes you're not writing your own program. Sometimes you'll be reading somebody else's program. If somebody else's program gives you a condition like this junk here, then how do you evaluate it? How do you understand the meaning of that? Well, it's kind of complicated looking at the original form. In other words, a programmer prior to getting the editing the program may give you a condition like this in a conditional statement, or the condition of a loop, or somewhere else in the program is a condition like this. So you, unfortunately, will have to maintain the program that somebody else has wrote, a long time ago, and that person is no longer around, and we cannot find that person anymore. So now it is up to you to interpret this junk here and say, oh, so that's really just saying x is less than 3. Okay? And that's why, understanding, logic and how to derive or simplify, logic is going to be helpful. So I will go ahead and try to find a class that will teach that kind of stuff. Interestingly, sometimes it's a philosophy class, not a mathematics class.
Yeah, there's a philosophy 320.
320? Okay.
It's kind of like this, but it's more with like using actual like grammar and stuff like that. So
Okay.
You get the logic idea, but I think it's good to take also.
Yeah, I think all of these classes, they kind of work hand in hand. One class will teach you something that is useful in another class. So when you take these classes together, well, not exactly like in the same semester, but when you take these classes, at some point of time, it will just help to reinforce everything else. Philosophy 320.
Prereq too, so you can use it for transfer credits.
It's a prereq, and I think this also counts as a GE.
Yeah.
Yep. And by the way, this class counts as a GE too, starting this fall, I think. Okay, so here we have philosophy 320, logic and critical thinking. Don't you think that has something to do with programming, the stuff that we are talking about in this class? Okay, so let's just take a look at this here. The basic principles of good reasoning. It focuses on recognizing arguments and identifying their premises and conclusions, inductive and deductive standard of evaluation, and it will cover what we have just talked about. Okay, it will cover the truth table, conjunction, disjunction, negation. Did they cover De Morgan's law? And
Oh, I don't know. I'm in the class right now.
oh, yeah.
I'm only in
Oh,
before.
okay. Okay, that's good. Okay. And there are no prerequisites, which makes it even better.
Not always.
Hmm?
Not always.
Not always.
No, because then you go into the class and you go, what? I didn't know any of this junk.
I know, because I'm teaching a class that has no prerequisites.
Yes.
But yet, the title of the class is Implementing Security on Linux. It has no prerequisite. No, sir, you do not need to know anything about Linux nor networking to take this class.
Really?
Well, those are advisory. We have
I don't believe
advisories.
you. I think the advisories should be bumped up to the prerequisites.
Yep. And there may be math classes too. In the math. Yep, go ahead.
So is Linux much more secure than Windows? Or
Only if you do the administrative stuff right. Windows can be locked down too. Windows is not inherently insecure. It's just that certain practices that people do, makes it insecure. For instance, I can give you an example. In XP Home, and I suspect this is true for all quote-unquote home edition of Windows, all versions of Windows, everyone by default is an administrator. That to me is just asking for trouble. Okay,
Because they
in
can
Linux,
install stuff, because they can install whatever they want.
you can overwrite system files. You have full admin right to do all kinds of nasty stuff. In Linux, okay, by default, with most distributions that I know of, okay, there could be other distributions that I do not, but with most distributions, a user is nothing more than a regular user. In other words, if a user goes to a questionable website and get quote unquote infected, only his or her files can get affected, but it cannot crawl the way to system files, except in certain extreme cases where the system itself is also has security holes. So it's this kind of stuff, and also if you look at Windows, from the operating system perspective, a lot of the features of Windows are implemented by DLLs. Okay, now this is kind of getting technical, but the DLLs exposes a much bigger interface to the kernel, the core part of Windows, than Linux. Linux, if in order for any application to talk to Linux, the interface is like this big. Okay. Now, granted, even with an interface only this big, you can still have security holes. But it's easier to test and check and double check when your interface is only about this much. But Windows has a gaping hole to the kernel of the operating system, which makes it, technically speaking, much harder to double check everything and make sure everything is secure. So definitely out of the context, out of the scope of this class, but since someone asked. Okay, in math classes, computational arithmetic. That's kind of interesting. Numbers, fractions, decimal, problem solving, and applications.
Usually, it used to be called basic arithmetic.
Yeah, I think it's like a really
They changed it.
Computational. Pre-algebra. And I can tell you, algebra is very useful, regardless of what you're doing. So, if you have a chance to take algebra, go ahead and do it. I'm specifically looking to see if they have anything related to logic. Just algebra, introduction to mathematical ideas, discovery, symbolic logic, problem solving. Okay, let me see if I can find this set. Nope. Oh, there we go. This is useful, but it's a class with 3 units and a lot of the other stuff that is not immediately useful in a class like this. But I think it will still be a good, useful class to take if you want to kind of brush up your logic, geometry, combinatorics, and so on and so forth. Okay, so getting back to this class here.
Where does it say it's not recommended for elementary school teachers?
I do not know.
I don't want you going back and torturing the kids like this.
I have ideas to torture kids. Okay, so getting back to, yes, go ahead.
You said that you suspect that post 3 is x is less than or equal to 3. How did you get less than? Isn't the condition less than 3?
Well, that's just a suspicion. Okay, so I
So
don't.
you can just put less than 3 and that's it, technically.
No, it has to be less than or equal to 3. Because as we'll see, this will work out if you cross out the equal to, it does not work out anymore.
But how would you know beforehand that you need to do that? You just do that.
You just kind of try it out in one way or another. It has something to do with the exit condition itself, for sure. Okay, but that's not the only thing, because the equal to has to be there. Okay, let's take a look at this derivation. So I know what you're asking, but I think this will answer your question too. Okay, at this point, okay, let me just use the mouse pointer again. At this point, we cannot do any more simplifications because the expression has gone from this humongous, useless thing to exactly what it means. Okay, we have done a lot of simplifications, and it cannot be simplified anymore. So the only thing left to do is actually go ahead and do the substitution. So after the substitution, we have something that looks like this. X minus 1 is less than 3. Now here comes the magic, because you can say that, oh, this is x is less than 4, but the assumption was, what was it?
X is less than or
x
equal
is
to
less
3.
than or equal to 3. So they do not seem to be the same. But what if I tell you x is an integer?
Then they are the same.
They are the same, okay? So I can say x is less than or equal to 3. This works if x is an integer. Now, how do I know x is an integer? I mean, Tech, you never told us anything about, x is an integer.
It started off as an integer and you're only adding integers.
Exactly. It started off with an integer value, and every time you change it, you're only adding 1 to it. So it remains an integer all the time. Okay, so that's why we can carry that one extra step to make it the same as the assumption itself, as my suspicion. So that works out. Okay, if I think that post 3 is x is less than or equal to 3, go through the normal derivation. Everything works out. It becomes itself. That's good news, because now we know that post 3 is really just x is less than or equal to 3. Unfortunately, that's not what we are looking at, what we are looking for, because what we're looking for is the post condition of the entire loop itself. But knowing this makes it so much easier to figure out what is the post condition of the entire loop. Okay? Because the post condition of the entire loop, which is post 4, depends on a few things. First of all, I know I cannot get out of the loop unless x is greater than or equal to 3. That's an absolute requirement to get out of the loop. Is everybody convinced of that fact?
Question.
Yep.
If x is less than or equal to 3, then how would equal to 3 be able to get out of the loop? Would it just be x is greater than?
But this is a post condition. This is after line 3 performs its operation.
Okay.
So if you look at the picture here, this is post 3 here.
Right.
And this condition gets carried all the way back into here, and we can go from here to here.
Okay.
So that's why the equal to is important, because that's how we can escape from the loop again. Okay. So now but that's a good question, because it relates to exactly what I'm talking about right now. Is to get out of the loop, we need x is less than 3 to be false. That means x has to be greater than or equal to 3 in order to get out of the loop. Okay? Even though that's the absolute requirement, we also know something else. There are two things that we know that can possibly be true. Okay? Those two things basically are the same thing. We possibly, even though it doesn't happen in this case, we may not even go through one iteration. In this case, we know we have to go through at least one iteration because x is 0. But in general, with a loop like this, with a pre-checking loop, it is possible that you don't perform a single iteration and get out. Okay, that's fine. We'll just put that here. Okay, that's the precondition if we did not go through at least one iteration. And the other condition is we went through at least one iteration. If we went through at least one iteration, then a purple line applies, which means the post 3 will still be true by the time we get out of the loop. Is that working out? Okay. So that means we also have to use a disjunction and say post 3 is one of the possibilities. So now we have to look at this whole thing and say, can we make sense out of this? X equals to 0, or x is greater than, less than or equal to 3. So, but we have seen something like this already. So we know how to simplify this side. What does it become? X equal to 0, or x is less than or equal to 3? Less than or equal to 3, because that's the less restrictive or the more general way. So we say x is less than or equal to 3. Can I find an x so that x is greater than or equal to 3 and at the same time less than or equal to 3?
Yes. 3.
X is 3. And so now we have the exact post condition of the entire loop. Okay? Attack, we could have traced this code and arrived to the same conclusion. Well, that's true, but what if I did not give you 3 here? What if I give you 3 gazillions? Do you want to trace the code through 3 gazillion iterations? Probably not. What if I tell you this is k, some kind of unknown k? Well, then you cannot even trace the program if this number, the 3, is k. Okay, so that's the value of using pre and post conditions, because we can leave a lot of stuff unknown to the point that you cannot actually trace the code, and yet we can use mathematics and proofs to work it out and say, oh, well, guess what? It doesn't matter, because we can just use math to prove that by the time the loop exits, x equals to 3 in this case. Are we doing okay so far? Does everybody understand the difference between tracing a program, tracing a pseudocode, versus using pre and post conditions to describe the outcome of an algorithm? Okay. Now, having said all of this stuff here, going through all the derivations and convincing you guys to take philosophy 320, I will just tell you one thing. I will not ask any questions about pre and post conditions of loops in exams. Not the first one, not the second one, not the final exam. Because loops are really nasty, so I won't even try to throw that in. Yep.
So we learned the forget process and the sub process.
Mm-hmm.
There's got to be one more, right? To figure out the precondition or the post condition, because the sub only works if the right-hand side, refers to left-hand side, and there's
and it's reversible.
Yeah, but if it's not reversible, what's the other function that you got to use?
If it's not reversible, then you usually can use the forget rule.
Okay.
Yep. Because there are only a few cases where the right-hand side is not reversible. This is one of them. Okay, x times 0. But in this case, this whole thing just becomes 0, and that's why it is not reversible. Regardless of the original value of x, they all map to 0. Okay. There are other cases, but they're all similar to this. Okay, they basically, the equation involves x, but they all go to one particular value. The only one, and I think that's the only very few cases that are not reversible, even though the right-hand side refers to the left-hand side. Okay. Yep.
On the post 4, when you put x is equal to 0, why do you have to put that in there if you never go back to line 1? You just go to line 2.
Post 4 here?
Yeah, well, you have to put, when you put x is greater than or equal to 3 and x is equal to 0, do you have to put that x is equal to 0 because you never...
Yes, you have to put it here because it is still one of the quote-unquote possible paths. In other words, if this is k and this is v, and I don't tell you what is k and what is v, then you have to think about that possibility. It works out here because we know this is 0. But what if I tell you the initialization is not to 0, but to some kind of value k, and then the loop here is going to use v instead of 3? Then they're both unknown. And when they're both unknown, then you cannot just say, oh, we'll just simplify the term immediately, because you cannot simplify the term immediately. Okay, so it gets a little bit more tricky when all the terms are quote-unquote unknown. This makes it easy because we have concrete values associated with everything. Okay. Any questions about loops? No questions? There's a particular name. Yep, go ahead.
I have a question. It says post 4 is equal to x is greater than or equal to 3. Post 4 means the 4 in the beginning where it says end while.
Post 4 is this condition here. Immediately after we exit the loop, what do we know? That's post 4. Yep.
You said we won't have pre and post for loops on the test, but
right.
How about homework?
No, not homework, because this is the only case that I can use, for explaining loops in a class. And those of you who are interested, this is called program verification or algorithm, correctness verification. And when you go to a 4-year university using the computer science program, they will have more advanced classes using completely different notations to explain the same thing. But they will also account for parallel threads and all kinds of cool stuff. This is just the starting point of automated verification. The idea is if somehow instead of having to do this manually, line by line, using our reasoning capacity, if you can automate this, okay, if you can make a mainframe computer, say, to be able to process, let's say 5,000 lines per minute, which is not really fast, it will still be nice, because just over maybe a few months, you can verify a fairly good sized program and say, we know for sure this program does what it's supposed to. So that's the holy grail of software engineering. It's called automated program verification. You are proving that a program will do what it is supposed to, using pre and post conditions, basically. Okay, let's go ahead and take a 10-minute break, because this is kind of thick stuff, and this will give people a chance to kind of go through this diagram, copy it on a piece of paper, and we'll come back at 9:25. I can stop the recording. Thank you. Has everybody signed the sign-in sheet? Yeah. One second, let me stop the recorder first.